Hello folks, we come to the part 6 video of this exercise 5.1 and we continue with this finding out whether it is going to be continuous, whether the functions are going to be continuous or how. So this is again a break function with function which has got breaks in the domain. So let's understand the domain first. We have minus 1, we have 1. On this side the function is defined as minus 2, and between minus 1 and 1 and it is defined as 2x, and after 1 it is defined as 4x. So we may have to look at the continuity at these 2 points. So let's first see at x equal to minus 1. So first we will consider the limit as x tends to minus 1 from the minus side, that means on this side. We know that it is defined as limit as x tends to minus 1. On this side it is defined as minus 2 constant function, value is minus 2, and on the right side it is defined as limit as x tends to minus 1 from the plus side. The function is defined as limit as x tends to minus 1. On this side the function is 2x, which means it is 2 into minus 1, which is minus 2, and f at minus 1 it's defined here, that is also minus 2. Function is continuous. Therefore limit as x tends to minus 1 from the minus side, minus 1 from the plus side, and f at minus 1, they are all equal, so f is continuous at x equal to minus 1. Then let's check what happens at x equal to 1. Okay, so at x equal to 1, let's see what happens. Consider the limit as x tends to 1 minus f of x, that means this side of 1. So limit as x tends to 1, we know function is defined as 2x. X tending to 1, very close to 1, can be substituted as 1. So 2 into 1, 2, and limit as x tends to 1 plus f of x means right side of 1, it is defined as 4x. 4 into 1, 4. So therefore and how about that is here itself we have got limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. So f is discontinuous at x equal to 1. So continuous at x equal to minus 1, discontinuous. Now on this side and all we should check at x less than minus 1. How is the function? It is minus 2 constant function, right? So f is continuous. Then at x greater than what? 1, f of x is 4x, which is a polynomial function. So there also f is continuous. That's how we discuss the continuity of this function. Now once we are done with that, we are going to the next question. Now all this time we were discussing continuity. Now that approach is changing, and what is happening is they have given us continuity, but they have given us unknowns in the functions, and those unknowns have to be found out. That is what we are going to see now. They give us a function f which is defined as ax plus 1 when x is less than or equal to 3. It is defined as bx plus 3 when x is greater than 1. The function is given continuous. So let's check what is given. Given that it's at continuous at x equal to 3 means limit as x tends to 3 minus f of x is equal to limit as x tends to 3 plus f of x. That means from both sides it is continuous. And yeah, before that let's understand the function also. 3, on this side it is defined as ax plus 1, and on this side it is defined as bx plus 3. Okay, so let's right away substitute limit as x tends to 3. On this side the definition is ax plus 1. On this side the definition is bx plus 3. X is tending to 3, so let's make the substitution. 3a tending to 3 close to 3 can be 3. So 3a plus 1, 3b plus 3. Let's solve. 3a minus 3b on one side. This can come here. 3 minus 1, which is 2. So 3 times a minus b. A minus b is 2 by 3. We are only able to find that. We are not able to get a direct answer, but we are getting that a minus b is 2 by 3. That's our answer. That's it. If the problem was done in was given in some other way, probably we would have got the answer. But here we can only get the value like this, that a minus b is 2 by 3. That's all. That's how we stop the problem. Now next question is, they give us that the function is continuous at x equal to 0. You should find lambda. Okay, after finding lambda, you should also check whether the function is continuous at x equal to 1. So let's start right away. Now if you want, you can also understand 0 on this side, it is defined as lambda times x squared minus 2x, and on this side it is defined as 4x plus 1, and at x equal to 1 they are asking us to check. That's it. So that we can do. So we have therefore at nothing at given. Yeah, they have given that limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x. They are given 0 minus means it is lambda times x squared minus 2x, and here 0 plus means it is 4x plus 1. So let's go for the substitution. X tending to 0, very close to 0, can be 0. So lambda times 0 squared minus 0, here 4 into 0 plus 1. So here nothing at all. Lambda into 0. Oh, is it? We're getting lambda into 0, and this 0 plus 1, 1. Cannot be determined because lambda itself cannot be seen. Cannot be determined. Some mismatch. We should get lambda equal to, no? The lambda itself, term itself is not surviving. So not possible to find. We don't get the value of lambda. So forget it. We have not got the value of lambda. Okay, at least they have asked us to check at x equal to 1. Let's do that. At x equal to 1. Let's consider the limit at that point. Limit as x tends to 1 f of x. What is it? Limit as x tends to 1 is, at this point it is 4x plus 1. So that is 4 times 1 plus 1. Tending to 1, close to 1 can be 1. So 4 plus 1, 5, and f at 1. In this range, it will be a same thing. 4 into 1 plus 1, 5. So limit as x tends to 1 f of x is f of 1. Therefore, f is continuous. At x equal to 1, it is continuous, but x equal to 0, though it was continuous, we were not able to find the value of lambda because the function was structured like that. Okay, that's about this. I'll take some more problems and come in the next video. Thank you.